All right, this is the number 6 final review, graphing quadratic equations. Just a quick reminder about Chapter 5, quadratic equations. We have graphing methods or forms, which are standard form, vertex form, and intercept form, and we have solving methods, which are factoring and quadratic formula. We're going to address the solving methods, the quadratic formula, and factoring, but we're also, in conjunction with that, going to address the intercept form of graphing because it's related to factoring. Okay, from page 278, number 29, you have 5x squared plus 7x plus 1 equals 0. We first find the a, b, and c. A is 5, b is 7, c is 1. This is not new. And then we're going to use the quadratic formula. So we're going to solve quadratic equations using the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And the quadratic formula gives you the x coordinates, and you will know the y coordinates because they're always 0 whenever you have x intercepts, because your solutions are your x intercepts or your roots or real roots. Again, these are the first two are the more common ways of talking about it, are going to be your x coordinates. So all you already know your y coordinates because they're always 0. So all you're doing is finding those x intercepts. So let's substitute values now. So x equals, and I'm going to make it negative 1 times b, which is 7, plus or minus the square root of, that's a radical symbol. b is going to be 7 squared, and then minus 4 times 5 times 1. And then that's going to be all over 2 times 5. X equals negative 7 plus or minus the square root of 49. Now this is going to stay subtraction, minus, because it's 4 times 5 times 1, which is 20. There's no other negatives. And it's all over 10. X equals negative 7 plus or minus. This is where you get your two answers, plus or minus. And 49 minus 20 is 29. Square root of 29 now, over 10. And square root of 29 cannot be simplified. So right here, and there's no perfect squares in it, that's what I mean it can't be simplified any further. Right here is one of your exact answers. So this is going to be one of your exact answers, but it's not the only one. As you know from your text, there are going to be some other ways of writing those exact answers. So this means negative 7 is being divided by 10, and it also means square root of 29 is being divided by 10. So your book, and this is or, not and, would also say you could write x equals negative 7 over 10 plus or minus the square root of 29 over 10. Now I personally like the first way better, and I think you'll be more likely to see the first way, but I want you to know that there is another way to write this. All right, now we're going to approximate it. You're going to use your calculator. Without a calculator, you really can't do this. You could get close, but you couldn't get the exact answer. So you're going to have your approximate answers. Which are going to be x equals negative 7 plus the square root of 29 over 10, and, because there's two answers, x equals negative 7 minus the square root of 29 over 10. Let's start with the first one. So the square root of 29, this is how you put it in your calculator. So the square root of 29 is going to be 5.38, etc., etc. Then you're going to add negative 7 to it, which is going to be negative 1.61, etc., etc. And then you're going to divide finally by 10. And that's going to be negative 0.161, etc., etc. So that x is going to be approximately negative 0.161, which means it rounds to the nearest hundredth, negative 16 hundredths. And it's approximate, so use those wavy equal signs. Okay, and then this one, I kind of forced the calculator to do it. I know that 29, I'm going to take the square root of it, 5.385, etc. But I know this is minus, so it would be plus a negative. So I want to change that to a negative. I can either just use my toggle to make it a negative, or I can multiply by a negative 1, and then add negative 7 to it. That gives you negative 12.385, etc., etc. Divide it by 10, which gives you negative, this is approximate, do that correctly. I need to make the approximate symbols. Approximate negative 1.238, which means negative 1.24, 1 in 24 hundredths. These are approximates. Now let's look at what they look like on the graph. I know you're not asked to graph usually, but you need to understand how this works. So negative 16 hundredths would be just to the left of 0, and that would be negative 16 hundredths, 0. And then negative 1 in 24 hundredths is just to the left of negative 1. So negative 1.240. Those are your x-intercepts. Now we don't know our vertex. This is a very rough sketch, but we do know that the parabola opens up because a equals a positive 5. So it would go up and be something like that. This is just a rough sketch. Remember, your solutions, there's exact solutions. Let's go ahead and highlight these. You have exact solutions, exact answers, approximate solutions, approximate answers. These exact solutions and answers can be plotted on a graph because they are the x-intercepts of your parabola. Now, another couple words that you might hear, just so that you're aware of it, are roots. I don't like that color. Let's go back. Let's choose a brighter color. Roots and real roots. Just in case you hear them, it's not anything new. It's just solutions or x-intercepts they're asking you about. Okay, so now you're going to try the next one on your own, and then you're going to go ahead and solve it and then check it. Okay, so on page 278, I'm going to have you work on number 33. Again, we're continuing to solve quadratic equations using the quadratic formula. And the quadratic formula is going to give you the solutions or the x-intercepts. And the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now on this one I want you to be careful. I'm going to take you through, I'm going to remind you on the a, b, and c. A is going to be 4, b is going to be negative 4. So in this right here, negative b, you want to go negative 1 times negative 4. Whenever your b is a negative, you need to make sure you do that. Go ahead and solve it. Think about what the graph would look like, and then turn it on and make sure you've got it correct. Again, a was 4, b was negative 4, c is negative 1. So it's negative 1, negative b, negative 1 times the b, which is negative 4, plus or minus the square root of b squared, which is negative 4 squared. Make sure your negative 4 is in parentheses, minus 4 times a, which is 4, times c, which is negative 1, all over 2 times a, which is 2 times 4. Negative 1 times negative 4 is 4, plus or minus the square root of negative 4 squared is negative 4 times negative 4, which is 16. You have a negative times negative 4 times 4, which is negative 16, times negative 1, which is positive 16, plus 16. 2 times 4 is 8 all over 8. 4 plus or minus the square root of 32 over 8. Now 32 has perfect squares within it. Now a lot of people would go right to 4, but remember 4, 9, 16, 25 are all perfect squares, and 16 also divides into 32. So it's 4 plus or minus the square root of 16 times the square root of 2. Square root of 16 times the square root of 2 is the square root of 32 all over 8. Square root of 16 is 4, so we have x equals 4 plus or minus 4 times the square root of 2 over 8. Now, this one is actually a little easier to simplify if you go to that form that we were talking about before. So x equals 4 divided by 8 plus or minus 4 times the square root of 2 over 8. Well, 4/8 simplifies to 1/2. And then this 4/8 is 1/2, but it's times the square root of 2, so plus or minus 1 times the square root of 2 over 2. Now, anytime you have a fractional amount, a rational expression that's all over the same denominator, then you can write it like this. X equals 1 plus or minus the square root of 2 all over 2. That's the best answer right there. This is, again, your exact answer. So let's go ahead and highlight that. This is going to be your exact answer. And this is going to be your approximate answer. So we split it apart now. It's going to be 1 plus the square root of 2 divided by 2, and x equals 1 minus the square root of 2 divided by 2. Putting in your calculator, you go square root of 2, which is 1.41, etc., plus you add 1 onto that. Get your equal key, you get 2.41, etc. You divide by 2. and that gives you 1.207, which rounds to 1.21. Now, for the next one, the x equals 1 minus the square root of 2, you still do the square root of 2, which is 1.41. Now, because it's going to be minus, it's like plus and negative, so if you have a toggle switch, you just switch it to a negative, or you multiply by -1. Then you add 1 on your calculator, put your equals key, gives you negative 0.414, etc. Then you divide by 2, which gives you negative 0.207, etc. And negative 0.207 rounds to negative 0.21 if you're rounding to the nearest hundredths. For your graph, you have negative 21 hundredths to the left slightly of the origin, and 1.21 is to the right of 1 slightly. This parabola opens up because your a value is 4, and you can see that the y, you found the x-intercepts. The y values are always 0 because these are x-intercepts. So again, just a quick reminder, when you are solving a quadratic equation with the quadratic formula, you're finding the solutions, which if you had to graph them would be the x-intercepts, and they can also be called the roots or real roots. Now we're going to move on to factoring to solve quadratic equations. Okay, these are a little more complicated factoring problems just because I want to practice these with you. You've got 2x squared plus 14x plus 24. Now, normally we just use AC method, but if you look carefully, you can see that 2, 14, and 24 have the common factor of 2. So 2 gets factored out first. We end up with x squared plus 7x plus 12 equaling 0. And that 2 will just go along for the ride. Just make sure you write 2 times x squared, 2x squared, 2 times 7x, 14x, 2 times 12 is 24. Now we have this x squared plus 7x plus 12. Now we're just going to use guess and check on that. So we bring that 2 along for the ride. So 2, we know it's going to be plus plus. Our factoring pattern plus plus. And this is going to be x, this is going to be x. Factors of 12, or 1 and 12, well 1 plus 12 does not equal 7. 2 and 6, well 2 plus 6 equals 8, so that's not going to work. And then there's 3 and 4, which 3 plus 4 will equal 7. So it's going to be x plus 3 times x plus 4. Now if we come over to the graphing side, I want to kind of do these at the same time so that you can see how they work together. This is the factored amount right here. Let's go ahead and circle it first. That right there is your factored amount. You use guess and check. This is going to be your p-value for graphing, and this is going to be your q-value for graphing. You do have to be careful though, because the pattern is, and let's go ahead and highlight, oops, let's go ahead and highlight this. Here is the pattern. It's x minus p and x minus q. So we are going to note that this is going to be plus 3, so it p would have to equal -3, and x minus q, so since you have x plus 4, it's q equals -4. So we would have the x-intercepts of this particular point. Let's go ahead and put intercepts here. Are going to be p0 and q0. So -3, 0, and -4, 0. And then we're going to plot those. Okay, so we come over to the graphing now. We've got this p plus q is -3 plus -4 divided by 2, which is -7 divided by 2, which is -3.5. And you can see that that's right between -3 and -4. To find the vertex, we use our -7/2 as our x-coordinate. I went ahead and used -3.5 to make the math easier on the calculator. Y equals 2 times -3.5 plus 3 times -3.5 plus 4, just plugging it back into this equation right here. And then I ended up with y equals 2 times -5/10 times 5/10. Well, 5/10 times 5/10 is 0.25, so -0.25. You take that twice, you get -0.5. So the ordered pair is -0.5. And then your intercepts were -3, 0, -4, 0. And I'm going to have to do another video. If you want to watch this, go on to the next video because I'm almost out of time. So you can take a look at what I've written here, and then I'll do another one on another video.